Today we will talk about extraction and isolation techniques. There are various methods used for the extraction and isolation: water distillation, water steam distillation, and solvent extraction. Last method is the versatile method used for the extraction and isolation. Methanolic extract of a plant, which is developed after the shade dried of the plant, dip into a methanol and to get the methanolic extract. Methanolic extract dissolved in a distilled water and partitioned with the water immiscible solvent and get different fractions like anhexene, chloroform, ethyl acetate, and butanol. By using different technique, GLC gas liquid chromatography, column chromatography, and flash chromatography. It's a different techniques, also HPLC. In an hexane, there are different type of compound are present: fat, waxes, less polar mono, cisky, diatriterpene, sterols, flavonoids, coumarins, lignins, carotenoids. In chloroform fractions, there will be present different compounds like medium polars, like monociscidiatriterpenes, steroids, flavonoids, coumarins, and lignins. In ethyl acetate fractions, more polar monocisci di and triterpenes, steroids, flavonoids, coumarins, and lignins. And in a last, and butanol, highly polar compound will be present, saponins, other glycosides, tannins, polysaccharides, and highly hydroxylated constituents. For alkaloids, actually different scheme is adopted to isolate and extraction. Structure elucidation. After the extraction, there is a determination of the structure of a compound. Different methods are used: chemical methods and spectral or other instrumental methods. Nowadays, spectral methods are preferred because they involve less wastage of sample. Best way is to use them together with some other physical and few chemical methods. In a chemical methods, uh, dehydrogenation, catalytic hydrogenation, ozonolysis, oxidation, epoxidation, dissolved reaction, addition reaction, hydrolysis, and derivatizations are included. In spectral and other instrumental methods, different techniques are involved in which optical rotation, reflective index, PMR, proton magnetic resonance, carbon 30 nuclear magnetic resonance, similarly HMBC, HMQC, COSY, NOSY, GCMS, EIMS, HRMS, FAB, and X-ray crystallography. Flavones. The flavones, which are also known as the anthocyanins, are hydroxylated derivative of a parent flavone to phenyl for chromone. Chromone. Here is a chromone, benzo, gamma, pyrone. Here is a position of gamma pyrone. And substitution at the position 2, here's a phenyl group. In almost all cases, position 5, 7, and frequently one or more of the position 3 prime, 4 prime, and 5 prime are hydroxylated. Position 5, 7, and 4 prime, 5, 7, and here's a 4 prime are generally unmethylated, but 3 and 5 prime, here's a 3 and 5 prime, are often methylated. Further, we will talk about structure determination. The general method of ascertaining the structure is to determine first the number of free phenolic, acetylation method, and methoxyl group, Ziesel method. Then the product obtained by alkaline fusion or hydrolysis are examined. Finally, the structure is confirmed by total synthesis or modern sophisticated spectral techniques. Flavone. This occur naturally as dust on flowers, leaves. When boiled with the concentrated potassium hydroxide solution, it gives a mixture of four products: salicylic acid, acetophenone, orthohydroxy acetophenone, and benzoic acid. The product which are obtained in the pairs 3, 4, and 5, 6 here's a, arise from the fact that the opening of the pyrone ring, here's a opening of the pyrone ring produces orthohydroxy dibenzoyl methane. After the opening, produce this compound, which is a beta diketone and undergoes um, degradation into two different ways. In general, all the flavones give a mixture of four products when degraded with potassium hydroxide. The intermediate orthohydroxy beta diketones, here's a compound, can be isolated if the flavone is heated with methanolic solution of barium hydroxide by the action of sodium peroxide in pyridine. But there is a total synthesis. The structure of flavones have been confirmed by their total synthesis. Some important syntheses are Robinson synthesis, Baker-Venkataraman synthesis, Kostanecki synthesis. Robinson synthesis: flavone is obtained when orthohydroxyacetophenone is heated at 180 centigrade. Here you can see that with benzoic anhydride in the presence of sodium benzoate. It's a firstly substitution at the hydroxyl group. After the removal of water molecule, flavones are produced. Baker-Venkataraman synthesis. Orthobenzoyl oxyacetophenone is isomerized to an orthohydroxy beta diketone by treatment with the base. Here is a treatment. Orthohydroxy beta diketone is formed. The arrangement of the result of the internal Claisen condensation. The acid catalyzed cyclization. Here is a catalyzed cyclization of the resulted diketone yield flavone. Here's the diketones and the formation of flavone. Kostanecki synthesis. This is a general method for synthesizing flavones and consists of condensing the ester of an alkylated salicylic acid with acetophenone. In the presence of sodium, Claisen condensation. Thus, for flavone itself, the reaction is carried out with methyl ortho methoxybenzoate and acetophenone. As you can see that treatment with the sodium metal is a Claisen condensation, and here's a cyclization after the removal of water molecule in the presence of acid at the position 2 3 unsaturation develop. Flavonol, 3-hydroxyflavone. It is widely distributed in the plant kingdom, usually in the form of glycoside. Flavonols shows two characteristics: absorption band 1 350 to 390 nanometer and band 2 250 to 270 nanometer, which are helpful in identification. When boiled with ethanolic solution of potassium hydroxide along with other fragment, it gives orthohydroxybenzoyl methanol. Here is a compound orthohydroxy and benzoic acid. This suggests that flavonols is 3-hydroxyflavone, 3-hydroxy-2-phenyl gamma chromone. This structure has been confirmed by various syntheses. Kostanecki synthesis of flavanone and flavonol. The synthesis involved the Claisen condensation of orthohydroxyacetophenone and benzaldehyde. As you can see that orthohydroxyacetophenone and the benzaldehyde in the presence of base that is a potassium hydroxide, develop a 2' hydroxy chalcone by the addition of ACl. Here's a cyclization. Overall, the here is a formation of keto pharma oxime derivative at the 3 position by adding a sulfuric acid pharma keto, and after that a enol flavonoid are produced. Agriflan omega synthesis. 2' hydroxy chalcone here's on treatment with alkaline hydrogen peroxide is first converted into 3 hydroxy flavonone and then into flavonol. Here you can see that peroxide treatment to pharma epoxide after the cyclization. Here is the oxidation and the diketone. Here's a keto and this one is a enol form. Next is quercetin. This occurs as the glycoside quercetin in the bark of Curious tinctoria. Quercetin appears to be the most widely distributed natural pigment. On hydrolysis with acid, quercetin forms quercetin and one molecule of ramenose. Here is the reaction. Estimation of hydroxyl group revealed that it contains 5 hydroxyl group, and Zesel method indicated the absence of any methoxyl group. On fusion with potassium hydroxide, fluoroglucinol and protocaticoic acid are obtained, which are described for 2 hydroxyl group in ring A and 2 in ring C. When quercetin is methylated, here is a methylation, dimethyl sulfate treatment with the quercetin. Pentamethyl quercetin is obtained boiled with the ethanolic solution of potassium hydroxide, 6 hydroxy alpha 2,4 trimethoxy acetophenone, and valeric acid are obtained, which also supported the previous assignment of hydroxyl groups. All the above cumulative results suggested that quercetin is 3 primes 4 prime 5 7 pentrahydroxy flavone, 3 prime 4 prime 5 7 tetrahydroxy flavonol. Here is the structure of valeric acid. This structure has been confirmed by various syntheses. Kostanecki synthesis. As you can see that substituted acetophenone reaction with the di substituted, that's a methoxy group benzaldehyde, and here is a unsaturation in the presence of hydroxyl group. After the treatment with the acid, there is a cyclization reaction of pentyl nitride. It's a formation of oxime, and after the treatment of sulfuric acid, we will get a dienolic form, and after that, here is a enol form, and this one is a keto form. And overall, by the treatment of hydrogen iodide, the demethylations, overall, we will get a polyolic compounds, that is a quercetin. Robinson synthesis. Alpha methoxy fluoroacetophenone is condensed with valeric anhydride in the presence of potassium salt of valeric acid, 3,4-dimethoxy benzoic acid. For convenience, this has been written as ARCOOH. Here's a structure of valeric acid, and this one is a valeric anhydride and salt of valeric acid. That's a potassium salt. And this one is a compound actually treated with the valeric anhydride, form this intermediate after the cyclization, and the removal of water molecule we will get at the position 2 and 3 unsaturation. On the treatment with the base, there is a removal of compound benzoyl compound, substituted benzoyl compound to form a polyols compounds, and after that there is a treatment with the hydrogen iodide. We will get ultimately at the 2 position, at the 3 position hydroxyl group. So overall 5 hydroxy at the different position curiosity we will get a ultimate molecule.